Hi students, once again welcome to my class. This is the fourth series of discussion on thermodynamics. I hope you are enjoying all the previous discussions. Once again, I stress you, the discussion has been based on the previous question papers and the strategy of asking questions. Therefore, these topics will help you to hit the question in the competitive examinations. Okay, today we can go to another very important piece of topics, that is internal energy, enthalpy, and first law of thermodynamics. Let us discuss what is internal energy first. Internal energy U, as you know, it is a sum of all forms of energy except energy due to position or movement of the system. Very careful about it. Internal energy does not include energy associated with the position and movement of system as a whole. Obviously, it is associate energy position, potential energy of, it include potential energy of particles, each components of the system, but it does not include the position of the system. Suppose you have a system like this gas molecules, clear. Each molecule have different potential energy. It has a potential energy, it has another potential energy, PE1, PE2. This is the part of internal energy. But as a system, it has a potential energy that is not the part of the system. That is not the part of the system. Sorry, that is not the part of internal energy. Similarly, it has a kinetic energy, that is kinetic energy 1, kinetic energy 2, but the system has a kinetic energy that is not the part of internal energy. Very careful. Point number 1. Now, internal energy is a function of temperature, pressure, volume, composition, mass of the system. Okay. Now, absolute value of internal energy cannot be calculated. You can calculate only delta U. Only delta U can be calculated. U can't be calculated. U can be calculated. Only calculate delta U. Delta U is nothing but heat change. Heat change or work change or work exchange. Heat change or work change, or heat exchange or work exchange. This is the introduction of internal energy. Now we can go to first law of thermodynamics. What is first law of thermodynamics? Simply, you have a system with an internal energy U1. You have a system with an internal energy U1. To this system, you are giving Q heat. Plus means giving the heat to the system. Not only heat, you are doing plus W, work done on the system. Then the final internal energy will be U2. Therefore, U2 minus U1, that is delta U, is equal to the change in internal energy because of two processes, that is plus Q plus W. That is, energy is conserved. That is the first law of thermodynamics. Now another option, just opposite option, you are taking heat from the system. Not only that, the system is doing work, expansion. This is expansion, this is compression. Compression. Here delta U, internal energy change is, because of these two processes, minus Q minus W. The internal energy change is minus Q minus W. Because internal energy of the system has been changed because of two processes, that is release of heat, release of work. Now another option, you have a plus Q but you have a minus W. Expansion but heating. This is cooling. Heating. What is delta U? Delta U is equal to plus Q minus W. Now reverse is possible. Okay. That is minus Q plus W. Here delta U is equal to minus Q plus W. Therefore, these are the four different types of first law of thermodynamics. You have four different equations for first law of thermodynamics that can be used, depends upon the data given in the question. Now, in all these cases, W is equal to, pressure volume work. That is, W is equal to minus P delta. Suppose, in all the cases, heat, whether it is plus Q or minus Q, in all cases, heat given or released by the system at a constant volume. Imagine, at a constant volume. All the cases, the heat released or absorbed at a constant volume, the work is pressure volume work. Therefore, no volume change because the process has been done at a constant volume. Therefore, in all cases, W is equal to 0. In all that cases, delta U is equal to Q, that is equal to QV. Internal energy change in that case is nothing but heat change. It can be plus or minus at constant volume. Therefore, internal energy change for an isochoric process, nothing but a heat change of the system. Very careful. Internal energy change for an isochoric process, nothing but heat change of that system. Now we can go to next. What is enthalpy? What is enthalpy? H is equal to U plus PV. It is the sum of internal energy and energy required to achieve the pressure PV state. Achieve the PV state of the system, pressure volume state of the system at that condition. Suppose the system at pressure 180, the system of volume. To achieve that state, it should spend some energy, that is called PV energy. This PV energy is significant only if the system is gaseous or contain gaseous component. If system is solid or liquid, H is equal to U. No difference. H is equal to U, no difference. H is not different from internal energy if system is solid or liquid. Or for a reaction you have A gas, B gas. Number of moles of gas in reactant side and product side are equal, where H is equal to U or delta H is equal to delta U. Here also, in the solid and liquid case, delta H is equal to delta U. Therefore, delta H and delta U will be a different identity, different objects, different idea when a gaseous system is involved or a gaseous component is involved. Okay, that's all about our enthalpy. Now we can go to the relation between enthalpy and internal energy change. That is, H is equal to U plus PV. Delta H nothing but delta U plus delta PV. Normally, if at a constant, enthalpy is at a constant pressure. At a constant pressure, delta H is equal to delta U plus P delta V, because V delta P is equal to 0 at constant pressure. Enthalpy is measured at a constant pressure. Now, this at a constant pressure, delta H is called to QP. We said that delta H and delta U both are equal in terms of heat, and this is QV, we already proved. Now what is this tell? We know that PV is equal to nRT, delta PV is equal to delta nRT, where R and T are constant. Therefore, delta PV is equal to RT delta N. This N is responsible for gaseous substance only. This N is significant for gaseous substance only. Therefore, I write like this: RT delta Ng. Now the delta is applicable only for Ng, gaseous substances. Therefore, these are the two important relations which connects delta H and delta U. There is always questions in competitive examination connecting these two parameters. Let us see some questions from the previous examination. First question. See the first question. Consider CO plus R42 gives CO2. Delta U of the reaction at 300 Kelvin is minus 281.8 kilojoule per mole. What is delta H? This is a question. Very simple. Delta H is equal to delta U plus delta Ng RT. The first you have to calculate delta Ng. Delta Ng, number of moles of gaseous products. How many moles of gas? This is also gas, this is also gas, this is also gas. Given in the question, don't worry about it. Here, what is the number of moles? 1. In the product side, that's all. Minus, what is the number of moles here? 1. What is the number of moles here? Half. That is 1 minus 3 by 2, that is 0.5. Minus 0.5. Okay. Therefore, delta H is equal to delta U is given to minus 281.8 minus 0.5. Value of R is equal to 8.314 joule Kelvin. Molarity minus 1. Dear student, very careful. Therefore, it should be converted in kilojoule, because here kilojoule is given. This is kilojoule, molarity minus. This is only the carrier state. Therefore, into 8.314 into 10 raised to minus 3. Temperature is given into 300. Okay? Yes. This is all you will get to 29.3 kilojoule. Sorry. 293.1342 kilojoule, something like that. You solve it, very simple. Now I will go to another question. Question number 10. I just give you the indication of questions. You can solve the questions yourself. See this question. The following reaction is carried out at 1 atm at 300 Kelvin to H2 gas plus O2 gas gives to H2 or liquid. Delta U for the reaction, delta U of the reaction is 500 kilojoule. Calculate value of delta H. Calculate the value of delta H. Very simple. Delta H is equal to delta U plus delta NgRT. What is the delta Ng here? Product side liquid 0. It's a liquid, therefore does not count. Here it is gas 1. Here it is gas 2. That is minus 3. Therefore 500 minus 3 into 8.314 into 10 raised to minus 3 because it is kilojoule. It is kilojoule into 300. That's all. You can solve it. Okay. Now next question. Yes. See this question. Let me check the video. The standard enthalpy of formation, the standard enthalpy of formation of CF2Cl ethane variety from its constituent elements in the standard state is minus 900 kilojoule per mole. What is delta U0 formation of the reaction? Okay. Delta H0 formation is given, delta U0 formation. What is it? This is formed from its standard elements. And how do you? This is our products. CF2Cl, CF2Cl, CFF, FF, Cl, FF, FF, Cl. This is formed from its constituent element. What are the constituent element at the standard state? Okay, we have a carbon, graphite 2 moles, fluorine 2F2. This is graphite, not gaseous state. Gas, chlorine Cl2, gas, you will get this. Okay, delta H0 is given. Therefore, delta H0 formation is equal to delta U0 formation plus delta NgRT. At 300 Kelvin, temperature is given in the question at 300 Kelvin. Okay, this is given. You want to calculate. Here also you can calculate delta Ng. delta H. Okay, this is gas. These are the gas. Therefore, delta Ng is equal to. Sorry. I am really sorry. This is liquid. This is liquid. I am really sorry. Therefore, product side 1 mole 0. Here this 1 mole. Sorry, here this is question gaseous state. It is. Therefore, this is gaseous state. I am really sorry. 1 minus 1 plus 2. This is gaseous state. Therefore, 1 mole. Here 1 mole. That's given. Here 1 mole plus 2 mole. This is not gas, but it is graphite. Carbon at the standard state is graphite. Therefore, it is minus 2. Therefore, you calculate this. You know this kilojoule. You know this is minus 2. You know the value of R, 8.314 into 10 raised to minus 3 in kilojoule. Temperature is 300. You can solve it. Very simple. Therefore, this is another very important piece of information that will help you to solve the question from these topics. Okay, keep in touch. Watch all the videos and wait for next videos. We can move together, qualify the examination. Okay, have a nice day.